Our next speaker is Laurie Spittler, who has a paper with Laura Sullivan, which confusing Laura and Laura.
We're everywhere.
Please.
Hello, everybody. So I am Laurie Spittler. I am the Industry Manager for Construction for Autodesk. Today I will be speaking about design thinking as a method of improving communication efficacy. And do I have a clicker? Clicker doesn't work. I have a pointer. So today I'm going to take you through a few quick items. We're going to discuss concepts that I'm using in my paper to build the case study. We're going to discuss a case study, which is from an immersion trip Autodesk did in Rwanda. You will note my fine Rwandan fashion. And then we'll examine the results and discuss the results of our case study and how it can be applied to construction. So the first, I want to set the frame of reference for this paper. We talk a lot about construction theory. We talk about production control. We talk about the last planner system. Really, the context in which this paper and this work should be viewed is within the linguistic action theory, and specifically looking at a project as a network of commitments between people. The second concept I want to discuss is the idea of wicked problems. So the term wicked problems we actually borrow from social planning. It was developed in the 1960s and the 1970s, famously by Horst Riddle. It has been introduced previously to the IGLC by Glenn Ballard, among others, talking about the problem of setting project definition as a wicked problem. So what is a wicked problem? We can go through and you can look, there's many different definitions, there's many different items that you can look at to set a wicked problem. Basically, a wicked problem is a problem that is so complex and so indeterminate that it defies a simple problem setting and a simple solution. So I want to pull a few of these items forward. The problem is not understood until after the formulation of the solutions. You actually truly do not understand the nature of the problem until you've formed a solution. The solutions are not right or wrong. There's no way to tell that you have the correct answer to, or the correct solution to that particular problem. Wicked problems have no given alternative solutions. Once you go, that is the solution to this problem. You have no option to go back and set a new solution. So given all these, I'm sort of like this sort of simplistic setting of the wicked problem, a form of social or cultural problem that is so difficult to solve because of incomplete, contradictory, or changing requirements. So a classic example of this in the world is climate change. You know, so many factors coming in, so many factors contributing to climate change, no set solution, and really there's no clear way to set a definition and execute a solution to that particular problem. As we talk about this, and as we look back to Ballard's work on setting the project definition as a wicked problem, this sort of starts to apply to construction. As we look at any construction site, any form of construction execution, there's no correct answer to the way you build a particular project. The inputs are they're complex. You have different stakeholders in each project. You have different conditions in each project. Even if you're building the exact same building according to the exact same plans, your site conditions will be different. So we need to start recognizing not only project definition, but construction execution as a wicked problem. And that leads us to the question, how do we solve a problem that is not determinate? For this, we again go to theory and look to other disciplines. So Richard Buchanan, in a 1992 paper titled Wicked Problems in Design Thinking, proposes design thinking as a method that is well suited to wicked problems. So what he does in this paper is he draws a distinction between sort of linear scientific problem definition and problem solution, and introduces design thinking as a method that seeks to use multiple frames of reference to start defining a problem. There's no empirical way to define a particular problem, especially wicked problems. You need to look through and use different frames of reference to truly understand what that problem is and the frames of reference through which you can see that problem before you can arrive at a solution. So design thinking is a method of solution-oriented problem solving. There's different methods. They generally include a period of observation, where you're trying to understand the setting for that particular problem that you're trying to solve. So you observe, then we understand the different frames of reference, and then we start making. And what this is prototyping solutions and testing those solutions. So it can be an iterative process, but the important part is really spending the time in that solution definition, the problem definition. We can look at this another way in that there's a really divergent problem definition. We're not looking to define a particular problem, we're looking to understand the entire context of the problem. And then a convergent solution finding. From that range of possibilities, we can then narrow down and select the most appropriate solution for our particular application. I don't want to speak to any particular methodology, but I do want to note that there's many references out there where you can learn more about design thinking, including the Luma Institute, IDEO, Harvard Business Review. There's a wealth of information out there. So that brings us to our case study. Our case study took the form of a 2-week immersion project in Kigali, Rwanda. The participants were Autodesk. Autodesk, as part of our corporate culture, we elevate sustainability in all of our products. We support our high-impact future customers. We also would like to lead by example. So this involves sustainable business practices, and this also involves employee impact. This was an employee impact trip. We partnered with Mass Design. Mass Design is a design firm that is based in Boston and based in Kigali. They take a human-centered approach to design, and they believe in designing with people instead of for people. Additionally, we worked with ADC, which is the African Design Center. As part of Mass Design's mission, they are working to train local designers and local builders. There's a scarcity of design training in sub-Saharan Africa, so they started their own institute. They're in their 2nd year right now where they're actually working to train the future architects of Africa. So in this trip, we spent 2 weeks in Kigali, and we worked with them to impart some software skills, network with other local nonprofits, and address an issue of communication between Mass Design and their builders. The builders in Rwanda are not plan literate, and they mostly are not literate and do not speak English. And so Mass Design is having a trouble where they are building great works, they're doing hospitals across Rwanda, and they have to spend their time on site supervising the construction, supervising the building. So the initial question they asked us is, how can we teach our builders to understand our drawings? We didn't like that question. We thought we could go a little bit further with that. And so we started applying some whys. This is before we even got to the design thinking. Asking them, what is important, what is going on with your drawings, why don't they understand? And it turns out that Mass Design follows a very Western format of drawing. They follow the AIA conventions, complex references, complex geometry, and they're a complicated set of drawings for Western builders to understand. And we sort of went from there and arrived at the eventual question of how might we improve the effectiveness of communication between the design team and builders, looking at it both ways. And from here, we went into our design thinking case study. The observe portion of the design thinking case study was that we went to the site, we actually went to construction, and we had the builders tell us their experience of building that project. What was clear, what was not clear, from project to project, what did they learn? So we can see a stonemason here explaining how she set the stones in a particular wall. We then took the lessons from that site visit. You can see up at the top, there's a bunch of Post-its. This is also another way to use Post-its in construction. And we had the students and the architects put their experience and what they heard from the builders on that central wall. We then clustered those thoughts and those things into groups, such as issues that related to constructability, issues that related to understanding, issues related to sequencing. So we could start forming some categories of where the issues were and where communication issues were. We then applied those issues to a process map where we set where those issues occurred in the process and where they could have been mitigated. So again, observing and understanding the process. We moved from there to an empathy exercise where we actually had the students and the architects build a building without using language or architectural conventions to start understanding what it was like to start building from a set of instructions that is not clear to you. We had some great results. Every single construction problem that happens everywhere was represented. You can see here a bridge where they actually switched the poles because they built those off-site, and then they set them in the wrong location on-site or on the bridge. We had one bridge that was an exact mirror image of the design. It was quite amazing. And so we spent the entire first week just setting the problem and understanding the problem. And what we evolved from the question of how can we address communication is to an idea of prototypes. And we decided to develop a set of communication standards for max design that are understandable for the builders, so actually change the way they organize and communicate their drawings. Then we decided to develop a training program for their builders that increases plan literacy and encourages ongoing learning. Again, Mass Design's mission is to educate the local population and create a trade for them, so we felt this was very important. And then test the concepts with builders, so again, that iterate. So as a result, we worked on this, and we developed the Foreman and Builders Training Manual. What you can see here in the upper right-hand corner is the students actually teaching the builders the concepts of plans and sections and elevations using a projection. This is the first time anybody had spent time, that I know of, anybody had spent time with the builders actually explaining what the language of our drawings is. They went through and they actually had a model very simple model that they could take apart. And they had the builders draw sections and draw plans, which I found incredibly interesting. The second one from the bottom was the stonemason. You can see that she may have the doors in the wrong place, but she started to detail the wall. And then as part of the communication standards for designs, the students produced different types of drawings. So you can see in the top portion, the different types of drawings, and they had a discussion with the builders about what was effective, what was not effective, and what was the best for communicating. We had really interesting results. You'll notice the stickers below below each of the drawings. We had the builders vote on what was clear and not clear. So the yellow stickers were unclear. You'll notice the axon in the upper left-hand corner. The builders were very confused by that. They asked, what do we put in the spaces? Now, of course, I, as a construction manager, had immediately complimented the students. I was like, oh, that's a really nice drawing. That's incredibly clear. They were confused by what to put in the spaces. They were confused that the drawing went vertical and then went horizontal. Once the students explained what that was intended to show, they actually understood the concept. So it can show that we need to not take others' expectations for granted. We need to talk to them, understand what they are seeing, and then you can actually work towards a conclusion where perhaps once they understand what an axon is intended to show, it is a valuable drawing. Other notes, they were confused. Why do you have a material plan and a dimension plan on a plan? You're showing the same thing twice. What does that do for me? The architects thought they were being clear by providing two different drawings. Instead, they were confusing the builders. The details on the end, they said, quite fairly, I don't know whether that's a section or a plan detail. What does that mean? And so they took this information and they've incorporated this information into their drawing standards. And we really incorporated into their drawing standards. And essentially what happened is using the design thinking methodology allowed the team to use a specific methodology to explore the problem definition prior to moving to a solution. So really in this experiment, we spent an entire week on the problem definition. Had we just gone with that first question, how do we teach the builders, would not have been effective. We would have come up with a drawing set and explained to them how to read a drawing set. If we talked about the second question, it was the right question, it was too vague. That entire week of exploration allowed us to really understand and target our solutions. The important factors in this process, and I'd say this is actually as important as the problem definition, as important as the eventual results, is that we allowed for democratic contribution of information. By allowing the builders to talk first, and then by soliciting input through the use of Post-it notes on a board and then clustering, we avoid the propensity to conflate the information that somebody is giving with the importance of that person. We ensure that we get all points of view and are working with all points of view before we move towards a solution. The second point was empathy building between stakeholders. We spent a lot of time trying to understand other stakeholders' points of view. We've got to recognize that the way that we give information is not the way that we give information is not the way that other people receive information. So, quickly, applications for construction. I really think this can be used anywhere in the process, and it's great for a team to understand communication between themselves. A couple points would be developing processes, communication processes between stakeholders. You can take this exercise to apply it directly. You can use it for root cause of task failure. So you could have all the members who are involved with that task failure contribute their reasons and use the thought organization exercise. And then you can use it at the beginning of a project to collectively identify risk and how to mitigate risk on a project. So I will leave you with one final slide, which is my favorite image from the entire trip. And what we have here is the builders, the architects, students, Autodesk, looking at a set of drawings and talking about how to communicate. And I think that's the most important thing.